Thank you very much. And thank you very much, participants. My topic today is predictive data analytics for business decision making. And as Professor introduced me, I'm a data enthusiast and really more enthusiasm for prediction. So for those of you who are old enough, I think it was about 2008, there used to be an octopus called Paul who used to predict World Cup wins. And I think he was based in Germany. Unfortunately, he's now passed away. So, but he was very accurate, apparently 100% accuracy. So in the work that I do, we don't really hope for 100% accuracy, but we do try to be able to predict and learn from what predictions we make and improve. So I'll be talking about predictive data, but from the point of view of business, or trying to relate it to examples from HR. So predictive analytics is the use of data and statistical methods, machine learning, to identify the likelihood of future outcomes based on historical data. And I watched a presentation earlier today, and somebody mentioned this as well, to say predictive analytics is about what will happen. How can we tell what will happen, or how can we reduce the possibility of getting it wrong, basically? There are some attributes, because there are different kinds of analytics that we can do, but there are attributes for predictive analytics that I've used Gartner as my source. So first of all, as the name suggests, you emphasize prediction rather than description. So I want to know what is going to happen. It has to be quick, because if you're using it for decision making, you want it to be in time for you to make the decision. And then it has to be relevant to the decision. It can't just be something out there experimental. I want it to actually make an impact on my business. And it has to be easy to use, because the person who's going to be making the decision or trying to analyze this data doesn't necessarily have to be a data scientist. It could be anybody within the organization trying to make sense of the data. So those are the attributes that we will keep in mind when we're talking about predictive analytics. And although those are the attributes, there are very specific disciplines that deal with machine learning, with that kind of analytics. And those skills are necessary and will inform the way that you use your data in the organization. But you can, as HR practitioners or in whatever field you come from, still do predictive analytics using very simple tools. And I'll illustrate that in a minute. So when we talk about predictive analytics for effective decision making, there are considerations that you have to have in mind before you try to use this kind of method to analyze your data and to do a prediction. So unlike Paul the octopus, who did it for fun or for food, we do it because we want to solve a problem. You have to know what problem you're solving. There's got to be a problem for predictive analytics. What are you trying to predict? Why are you trying to predict in the first place? What is the context? So,
one. Testing.
All right. I'll assume the interruption.
Continue.
Okay, so what is the context? So we may have the same problem, but the contexts are completely different. I'll give an example.
Testing. Testing, 1, 2. Right, me. Testing, 1, 2. Testing, 1.
You check outside.
Testing, 1, 2. Is that picking up as well? 1.
Yeah, I think it's the next one.
What about
Sorry, Carina, I'm not sure where that is.
testing, 1, 2?
Still hearing you?
Yeah,
Just a minute ago.
Oh, okay.
All
Have
right.
you told them? Have you told them?
Yeah, they're informing them.
Okay, so let's continue and we'll just stop if it happens again. So I was just saying, you have to know the context my problem and yours might seem similar, but the contexts are completely different. So an example from an HR perspective would be, we are coming out of a pandemic and organizations making the decision whether to allow their workers to continue working from home completely or to come in 2 days a week.
Testing 2, doing 1, 2, you signal loss. Any doing 1, 2. If back from this one, no, testing 1 little bit, perhaps. 2, testing 1, 2, testing 2. That's interesting.
Robert, have you had this over the past few days? You've had this over the past few days? That's the first time. Okay.
Shall we wait?
Or should we wait for a few?
Okay.
You want us to continue or should?
Okay.
Do you want to take some questions? Bad, I have a question for you.
Oh, that was big. All right.
No, you threw some big terms there like machine learning and things like that. I think you may just want to explain what those do.
Okay, I was trying to avoid going into the machine learning description, but machine learning is a set of algorithms or set of usually, or in the past, for those of us who started from a software development background, you had to go and write down a set of instructions for the computer to follow. And then you input the data, it follows those instructions and produces an output. Nowadays with machine learning is that the algorithm that you use or the set of procedures will go into the data, which is called a training set, and learn from the data patterns without intervention of the developer. That's basically what machine learning is. And there are different kinds and they're from different circumstances.
Yeah.
Yes.
We should solve that. Yeah, enough money is going. I don't have money.
Okay. I think, well, okay, let's continue. So back to my point about context and the problem is you are trying to solve the problem of whether your staff can work fully remotely or come back half the time, or whatever decision you want to make. Now, it depends on your organization. If you're working even in IT within the same organization, for IT, we support on the ground most of the time. There has to be a presence on the ground. So the rules for IT might not be the same, might be completely different for the rules from another department. If you're working in a hospital, it's of course a completely different scenario. So while the problem is the same, the context is different. So in my slide, I say start with the context. What is the context in which you operate? And then what is the problem you're trying to solve? What kind of decision do you need to make? And when should the decision be made? Because in the attributes we said, predictive analytics is about doing it quickly. If it's a decision that requires a lot of thought, a lot of very accurate data, that might not be the right way for you to go. And so you need to also know what kind of decision you're making. And then what are the risks or the perceived risks of making that decision? Is it a decision that you can recover from quickly in case it's the wrong decision? Because the decision, you want to be effective in terms of making it quickly, but the impact will not be felt until post-decision. So you have to know what are the risks and if you can recover from that decision. And then we come to the data, which is the focus of this session. What data is available? If you don't have data, you can't really use predictive analytics because it won't work. What is the quantity of data available? Sometimes you might need 1 week's worth of data, but sometimes you might need 10 years worth of data. Do you have that data? And what is the quality? The quality in terms of completeness, consistency, is it accurate? Is it from the right time frame that you need? And what are the constraints? In HR, more and more, we're talking about personal data. That data is shared with you for a reason. So it might not be appropriate to use it for certain kinds of business decision making if it wasn't shared with you for that particular purpose. So for example, if a staff member shared with you their medical condition, and then you want to make a decision on whether you need to change your health related policies or you need to increase your insurance in a certain way, you've got to be a bit careful. For what reason did they share that data? And is that kind of analytics included in the reason for which they shared the data? If not, then you've got to perhaps explicitly tell staff what the data is going to be used for. And then there are the skills and tools. So analytics in itself is a skill that needs to be acquired regardless of what field you're in. It's not something, it's something that I believe comes with experience. The more you experiment with data, the better you become at reading the data, at making conclusions and knowing what data can do for you. So we have the subject matter experts who are the HR practitioners. In this case, if you're doing an HR related decision, because the context for me as somebody from IT, I understand it completely differently from somebody who has been doing HR for all their life. So I need to listen to the subject matter expert. You will have data scientists who will know what kind of algorithms will work best, especially if you're using machine learning. And then we've got the tools. The good thing is tools are becoming more and more easy to use. Many HR applications come with analytics tools built in their reporting capabilities. So you don't have to worry too much about them. The one thing I want to talk about a little bit is trusted algorithms. When you're doing predictions, you have to be careful. Certain algorithms, because we're talking about machine learning, we're trained on data sets that are not based in your context. They're not inclusive. So there was an instance a few years ago where it appeared that some analytics that was being drawn from CCTV camera footage was more likely to mix up people of a certain shade of color. It couldn't distinguish the features because the training data set didn't have enough data for that section of the population. So you also have to be careful with the way that you use your algorithms. And then the methods from which you draw conclusions, again, in decision making have to be agreed, and you have to govern the data. And I'll come back to the governance in a minute. Just as an example, this data is data that was provided by IBM, but it's provided really for use by students, data science students, and it's looking at employee attrition. So this is the what the data shows. They used a variety of machine learning algorithms to come to these conclusions. So they're looking at the likelihood that an employee will leave the organization. And they look at various factors. So you have how far they live from work, how often do they travel, what department do they work in, and all of these are being analyzed to tell you which employees are likely to leave after. This was for a 2-year time frame. It's not showing on the slide, but it was for 2 years. Which employees are likely to leave in the next 2 years? Again, this is a database for learning, but the problem probably would be we want to reduce the amount of turnover in the organization, and we want to know what factors, what can we do? So we want to predict how many will turn over. Once we predict, then we go back to the prescriptive analytics to say, what can we do to solve the problem? So in this case, there's some relationship between how often people travel for business and whether they will stay long. So you might say we might widen our travel policy so that more people travel because it seems to be an incentive for them. There is some relationship between how far they live from the office and how long they stay. So perhaps it's something to think about. Maybe you become more flexible with your remote working so people don't have to travel long distances into the office. And then what department they work for, whether they are male or female. In this case, it's looking at 2 genders. And all of this is just designed to help you say if a turnover is likely of 17.11%, is that acceptable in the first place? If it's acceptable, fine, you don't have to do anything about it. But if your target turnover is 10%, then you want to intervene, you then go and analyze further and do a prescriptive analysis to say, this is what we are going to do about this problem. So this is an example. This data is freely available, and it is HR data gleaned from actual organization, but it's been anonymized, so you don't have to know which organization it is. Now, to do this kind of analysis, this one was done using Tableau. So some organizations use Tableau, but my tool of choice is currently Power BI. It comes with your Microsoft licenses, and it's fairly easy to use. If you're an Excel user, you can start to use it, and it produces results very quickly. So once you have your data in Excel, you can then use your analysis, and it is suitable for any level of skill, beginners right up to the expert data scientists. You can use Power BI and still get very useful insights. And you can, the insights are presented in such a way that if you're presenting this to your management or board, it's in very simple charts that are easy to understand. So on your journey to predictive analytics, these are some of the takeaways that I think would be useful. One, you've got to govern your data. And what do we mean by govern your data? You have to know what data you have. You have to know who is in charge of the data, how accurate the data is, and what its purpose is. You have to have very specific procedures around how you use your data, how often it's updated so that it's kept up to date, and what is the value of that data to the company. Because if you don't value, you don't know what that asset is, you don't then resource it correctly. You want to make a quick decision, you've got the people to make the decision, but you don't have the data to inform the decision. That's not really helpful to the organization. So you have to govern your data. You've got to build your analytics capabilities at all levels. Very simple analytics right through to the experts if you want them. And then you have to know, what decisions will I make using predictive analytics? Not all decisions are suitably informed using predictive analytics. So your methods have to be transparent, and you have to know what you're going to do with that data. So then the different kinds of an analysis. So prediction is what we've talked about. Prescription was talked about in the morning. Experimental, just to explore your data, because you'll find insights that you didn't know about. And it also informs what other data you need to collect. And then measure the impact. I made this decision using 6 months worth of data, and it turned out to be a wonderful decision. That means I can continue to trust my data, and I should continue to build on it. Or I made this decision and I was misinformed. My data was not accurate enough. So I need to go back and improve on the accuracy. And that's the learning process for the organization, and the continual cycle to go on improving your ability to use predictive analytics for your business decision making. Thank you very much.